Well, we know how to figure out the area of a trapezoid. We have videos where we derive this formula. But the area of a trapezoid, just put simply, is equal to the average of the lengths of the bases. We could say base 1 plus base 2 times the height. And so what are our bases here? And what is going to be our height over here? Well, we could call base 1, we could call that segment CL. So it would be the length of segment CL right over here. I'll do that in magenta. That is going to be base 1. Base 2, that could be a different color. Base 2 would be the length of segment OW, or B2 would be the length of segment OW, right over there. And then our height H, well, that would just be an altitude. And they did one in a dotted line here. Notice it intersects the base 1, I guess you could say segment CL at a right angle here. And so this would be the height. So if we know the lengths of each of these, if we know each of these values, which are the lengths of these segments, then we can evaluate the area of this actual trapezoid. And once again, if this is completely unfamiliar to you, or if you're curious, we have multiple videos talking about the proofs or how we came up with this formula. We can even break down a trapezoid into two triangles and a rectangle, which is one way to think about it. But anyway, let's see how we can figure this out. So the first one is, what is B1 going to be? B1 is the length of segment CL. And you could say, well, look, we know what the coordinates of these points are. You could say, let's use the distance formula. And you could say, well, the distance formula is just an application of the Pythagorean theorem. So this is just going to be the square root of our change in x squared. So our change in x is going to be this right over here. And notice we're going from x equals -4 to x equals 8 as we go from C to L. So our change in x is equal to 8 minus -4, which is equal to 12. And our change in y, we're going from y equals -1 to y equals 5. So we could say our change in y is equal to 5 minus -1, which of course is equal to 6. And you see that here, 1, 2, 3, 4, 5, 6. And the segment that we care about, its length that we care about, that's just the hypotenuse of this right triangle that has one side 12 and one side 6. So the length of that hypotenuse from the Pythagorean theorem, and as I mentioned, the distance formula is just an application of the Pythagorean theorem. This is going to be our change in x squared, 12 squared, plus our change in y squared, so plus 6 squared. And this is going to be equal to 144 plus 36. So the square root of 144 plus 36 is 180, which is equal to, let's see, 180 is 36 times 5. So that is 6 square roots of 5. Let me not skip some steps. So this is the square root of 36 times 5, which is equal to, square root of 36 is 6. So 6 square roots of 5. Now let's figure out B2. So B2, once again, change in x squared plus the square root of change in x squared plus change in y squared. Well, let's see, if we're going from, we could set up a right triangle, if you like this, to figure those things out. So our change in x, we're going from x is at -2, x is going from -2 to +4. So our change in x is 6. Our change in y, we are going from y equals 5 to y equals 8. So our change in y is equal to 3. So just applying the Pythagorean theorem to find the length of the hypotenuse here, it's going to be the square root of change in x squared, 6 squared, plus change in y squared, plus 3 squared, which is going to be equal to, 36 plus 9, which is 45. So square root of 45, which is equal to the square root of 9 times 5, which is equal to 3 square roots of 5. And so we only have one left to figure out. We have to figure out h. We have to figure out the length of h. So h is going to be equal to, and so what is our, if we're going from w to n, our change in x is 2. change in x is equal to 2. We're going from x equals 4 to x equals 6. If you want to do that purely numerically, we would say, okay, our endpoint, our x value is 6, our starting point, our x value is 4. 6 minus 4 is 2. You see that visually here. So it's going to be the square root of 2 squared plus our, let me write that radical a little bit better. So it's the square root of our change in x squared plus our change in y squared. Our change in y is negative 4. Change in y is negative 4, but we're going to square it, so it's going to become a positive 16. So this is going to be equal to the square root of 4 plus 16, square root of 20, which is equal to the square root of 4 times 5, which is equal to 2 times the square root of 5. It's nice that the square root of 5 keeps popping up. And so now we just substitute into our original expression. And so our area of our trapezoid is going to be 1/2 times 6 square roots of 5, 6 square roots of 5, plus 3 square roots of 5, plus 3 square roots of 5, let me close that parentheses, times 2 square roots of 5, times 2 square roots of 5. And let's see how we can simplify this. So 6 square roots of 5 plus 3 square roots of 5, that is 9 square roots of 5. Let's see, the 1/2 times the 2, those cancel out to just be 1. And so we're left with 9 square roots of 5 times the square root of 5. Well, the square root of 5 times the square root of 5 is just going to be 5. So this is equal to 9 times 5, which is equal to 45 square units, or units squared.